Extrinsic pathway. It starts when trauma damages the blood vessel and exposes the cells under the endothelial layer, something like smooth muscle cells which have tissue factor or factor 3 in their membrane. Now that it turns out there is an enzyme called factor 7 that is floating around the blood, and some of it is active, meaning that it is already set to proteolytically cleave other proteins. When it is in that state, it is called as a factor 7 or 7A, meaning it is active. Factor 7A binds to a tissue factor and a calcium ions which get released nearby activated platelets, and it forms a 7A tissue factor complex on the surface of the smooth muscle cell. Both the calcium ions and tissue factors are cofactor, meaning that they need to bind to an enzyme, factor 7A, in order for them to allow to really get going. This complex then cleaves clotting factor 10, yielding the active form called factor 10A. Once factor 10A is generated via the extrinsic pathway, it cleaves factor 5 into 5A, then it uses factor 5A into calcium ions as a cofactor to form the prothrombinase complex, which activates prothrombin or factor 2 into just plain old thrombin of factor 3A. In fact, each prothrombinase complex can activate thousands of thrombins, so there's enormous amplification that occurs at this step. Thrombin uses calcium ions as a cofactor, and it has a number of procoagulative effects. First, thrombin binds to receptor on platelets, causing them to activate. The activated platelets change their shape to form tentacle-like arms that allow them to stick to other platelets. Second, thrombin activates three cofactors: factor 5, which is used in the common pathway; factor 8, which proteolytically cleaves fibrinogen, or factor 1 into factor 1A, also known as fibrin. Third effect of thrombin on fibrinogen plays a big role because fibrinogen is soluble in blood, but fibrin is not. So fibrin precipitates out of the plasma to form long protein chain that looks like a rope. The fibrin tethers platelets to one another, holding the platelet plug together. And fourth, thrombin proteolytically cleaves stabilizing factor or factor 13 into factor 13A. Factor 13A combines with the calcium ions cofactor to form crosslinks between the fibrin chains, further reinforcing the fibrin mesh. Next is the intrinsic pathway. It starts when a circulating factor 12 comes into contact with negatively charged phosphates on the membrane of activated platelets or subendothelial collagen exposed by trauma. Then it undergoes conformational change to get activated into factor 12A. Factor 12A proteolytically cleaves factor 11 into factor 11A, which combines with a calcium ion to cleave factor 9 into 9A. Finally, 9A forms a complex by a calcium ions and factor 8A. And this complex proteolytically cleaves factor 10 into 10A. It is important to note that factor 8 degrades rapidly in the blood if it's not bound to a protein called von Willebrand factor, which is released by activated platelets and endothelial cells during primary hemostasis. Next is the coagulation factors. Factor 1, fibrinogen, it is synthesized in the liver. It is made up of 3 peptide chains. Factor 2, or prothrombin, it is also known as prethrombin. It is almost entirely consumed in clotting. Factor 3, tissue factor, also known as tissue thromboplastin. It is increased in the lungs and brains. Factor 4, calcium, ionized state, is needed for coagulation. Factor 5, or also known as labile factor, it is the most unstable coagulation factor. Factor 7, proconvertin, also known as stable factor. It is synthesized in the liver. Factor 8, antihemophilic A factor, also known as platelet cofactor 1. It circulates in blood bound to von Willebrand factor. Factor 9, antihemophilic B. It is also known as Christmas factor. Half-life 24 hours. Factor 10, Stewart-Prower factor, also known as thrombokinase. Half-life is 40 hours. Factor 11, plasma thromboplastin antecedent. It is also known as antihemophilic factor C. Half-life 45 hours. Factor 12, Hageman factor, also known as glass factor. The actual site of production is unknown. Factor 13, fibrin stabilizing factor, also known as Lucky Laurent factor. The half-life is 3 to 12 days. Next is prekallikrein, also known as Fletcher factor. Half-life is 35 days. Last, high molecular weight kininogen, also known as Fitzgerald factor. The half-life is 6.5 days.